Welcome to Geology, everybody. So we're going to look at relative dating. The two types we got to do are relative and absolute. Start with relative. In your book, it's section 19.2. What I also have for you is a PDF of some notes. If you want to use this, use it. If not, if you just want to do it in the video, check that out. That's fine. Whatever works for you. So relative dating or geochronology is the idea of putting events in order. In other words, what is older versus what is younger. This, we're not going to do anything with numbers here. That would be what we're doing in another video, absolute dating. Techniques to tell exactly how old a rock is with numbers. That's not this. This is older, this is younger. So there's a bunch of rules for figuring this out. And then when you apply these principles, you can go to rock outcrops that maybe look kind of like this. These are drawings to represent what they may look like, and figure out, hey, in order for this rock to look like this, these things must have happened. So to be able to do that, though, you need these rules. So here on the sheet, or right along here in 19.2. All right, so superposition is an easy one. That's what this first one is. Oldest layers, things that land on the surface of the earth, the oldest are going to be on bottom, youngest are going to be on top. For example, if earlier I stacked these three books one at a time, which one would I have had to have put down first? Especially if I can't. I mean, with rock, you can't like lift it up and stuff another one underneath normally, right? So if I put these down and just dropped them 1, 2, 3, the yellow, the white, the green, the older one has to be on bottom. If you get the newspaper but never like pick it up and read it, it just goes into your slot and falls on the ground every day, your older ones are going to be on bottom, your younger ones are going to be on top. That's all superposition. Laundry, throw your clothes in the corner. Don't do anything to them for a while. Where are you going to find the clothes you wore the longest time ago? Way down on the bottom. Yesterday's is on top. All the same stuff. So all I'm going to say down here is that this would be the oldest visible in that section. This would be the youngest visible in that section. That's all we're doing. That's what relative dating is. Older to younger. That takes care of that. That's superposition. So don't ignore the text. Go back and read through this. Because they'll go into better detail sometimes too. Original horizontality. That's this one. I didn't spell that right. Maybe I nailed it. Layers are deposited basically horizontal. That's awkward sounding. Layers are deposited in horizontal layers, but you get the point. The point is that when something like sediment lands, it doesn't really land at an angle very easily. The layers that you see will be of originally laid down flat. So this is from one of the documents at the beginning of the course. This is a mountain bike ride I took up in Watertown somewhere. Horizontal flat layers. So we can say from this, using the two rules that we've got so far, the older layers are on bottom, the younger layers are on top, and they're still in their originally horizontal position. If we came to this rock outcrop and they were at an angle like this, we'd have to say that means something else happened, and we'll have to figure that out. So what would those things be? Here's the idea. Laid down flat originally, oldest on bottom, youngest on top. And then if something like this happens, maybe we would add in there to say that folding took place. That's the name for that, like getting an arc like that. Or maybe we don't see them like bent, we just see them at an angle. So we would have to say, hey, at some point, tilting took place. That's what we'll do when you get down to the problems down here. These layers here, they're no longer originally horizontal. They're tilted. No big deal, just account for that. Say that tilting took place. All right, here's where my notes in the book diverge just a tiny touch. Let me pause it real quick. Okay, so we're good here. Lateral continuity is a fairly easy one. And I mean, in a place like a canyon, it's very easy to see. Lateral continuity. Whoa. Matching sediment jelly layers across the gap were probably originally continuous or the same. So, like across a valley like this, it's kind of a no-brainer. If you stand at a river valley in New York somewhere and you see a rock layer over here and a rock layer over here that kind of match, it's like, yeah, those were probably the same until this river came and created this valley by weathering and eroding out all the rock, right? Where it gets to be a little bit more interesting, and this is why I wanted to pause for a minute to find this section of the book. Come down to page 11, scroll down a little bit. Correlation is like the implication that you get off of this. So correlation would be if I were to go and pick through these rocks, study them, get what fossils are in there, take really careful and accurate notes. What could I do with this idea of lateral continuity? Here at this section, I can't see any lower than like right here. So what rocks are older than that? I don't know. They're buried. This picture did go, the rock did go a little higher than this picture indicates, but once you get to the top and you're at the surface, everything above that is gone, right? So here's like literally chapters in Earth's history, sediment that was laid down that formed rock, but it's only like one chapter or one section of a chapter. How do we know what happened before this? How do we know what happened after this? That's where correlation comes into play. Could I take those notes and go somewhere else and say, find, sorry, I should have pulled this up before. There's a really good rock outcrop right here. So where was I with that other trail? This is nearby. I was up in Watertown. This is near Henderson. This image right here. So could those notes that I took match any of these? And if so, maybe they match like right here. In which case, if the bottom of what I saw there is the top of this, then I could say, oh yeah, that matches right there. Now I've got to go below that, and I could say that that correlates. That gives me everything that's down below here. And then if you do that to the bedrock on campus, and you do that to the bedrock at anywhere down through the Finger Lakes, all of those cuts, you start to put together, you start to match, and you start to come up with a more complete story of Earth's history. So that's really like the most powerful thing within all this. Like these little sections, it's a little puzzle. We'll figure out how to do it. It's great, but the correlation is the big one because this has allowed us to say not just in one individual section, how did that little tiny moment of Earth's history go, but how did that little chapter go, and then match that with another chapter that gives us more story below it. Match that with another chapter that gives us more story below it. You eventually can build the whole book, right? That's what lateral continuity and correlation will do. So check that out in the book. Read that correlation section. That's far from complete. Yes, there's different ways of doing it with rock or with life, but that's the idea. Good job. All right, cross cutting, and this will be in your book too. Come on back up to where we were. Is one that is like very obvious, but sometimes it's hard to spot. Cross cutting relationships. If a feature cuts across another one, it must be younger than the thing it cuts across. Okay? This is a silly example of that, but what happened first? Was this paper manufactured or was it ripped in half? And if that sounds like a silly question, it really like is the same thing as this. What happened first? Was this rock formed or did it fault? Did it crack like that? It has to be that the rock was there. So when you do a cross-cutting thing, it lets you see that that feature that cuts across all the other stuff has to be older than it. It had to already be there in order to be broken. That's what I mean with this paper example. The paper had to exist in order for me to tear it. I got a cool animal version of this. So it's silly, but this is like the same thing. If we had a car, a motorcycle, a bike, a dog, a person, and another person, could we figure out which order these things took place in? And here's an excellent example of cross-cutting. Just take the bike and these green footprints. What had to happen first? Well, the footprint cuts across the bike trail, so the bike had to be there. That's what cross-cutting is. You can't cut across something that doesn't yet exist. All right. So what we'll see when we come back to rocks is that sometimes, and I know we haven't done igneous rocks yet, but sometimes igneous rocks, rocks that come from lava or magma, squirt their way up through the crust for various tectonic reasons. And when this happens, they cut across these other layers. So this we'll call, there's a couple different things we can call it. Let's just start with igneous intrusion. Since it cuts across these layers, it has to be the youngest thing. We'll also see where rock cracks and offsets. We'll call this a fault. And again, you can't break rocks that aren't yet in existence. So while the rocks were there, then they faulted. You cannot cut something that does not yet exist. All right, so check that out, cross-cutting relationships, which kind of includes, you know what, we got to put that on there. This baked context. It's a strange way to say it, baked context. I've never actually heard it phrased that way. What will happen? I'm going to zoom in a little bit. When this magma comes through, it's hot, and it's going to melt its way through the rock. But some of the rock doesn't get melted; it just gets altered by the heat, so that it's like it's what we're going to call a metamorphic rock. It's changed, but not so much that it melted, because if it melted and cools, then it's igneous. And it's not unchanged, it's not the original sedimentary over here. It was altered somewhat by that heat. That's what this book refers to as baked context. And again, that's the first time I've heard it phrased that way. You know, if you like it, go for it. I tend to call it, what I've generally heard it called, is contact metamorphism. It's a good sign to help you through figuring out what had to already be there. All these rocks had to be there in order to be metamorphosed. You'll see it when you do your practice ones down here. Oops, it's supposed to be all the way around X too. That didn't happen. I'll fix that. But on the outsides of these, and again, those little things indicate then that those other rocks were there in order to be contacted by that. And inclusions is the next thing in your book, and that again works the same. I know we're kind of saying the same thing over and over again here. I'm going to save that chilled margins one for igneous rocks. So if you want to skip one paragraph, go for it. Inclusions would be if you've got a chunk of a rock in another rock. Again, it had to exist. You can't get a chunk of something that doesn't exist, right? So an inclusion is also pretty much the same principle. Which brings us to our last one, which is a little bit meaty, unconformities. And then we're getting there. Thanks for sticking with me. Unconformities. I did not. Occasionally, rock will be removed by the process of erosion. This removes rock from the rock record. So again, if we use that allegory of Earth's history being like a book, this removes pages from the book to where something's missing. And if you were reading a book and you finished page 74 and suddenly it went to page 92, you'd say, what the heck, right? Something's missing. And in the rock record, this happens all the time, where we've got pre-existing rocks, then some erosion, and then subsequent deposition on top of that. That's what an unconformity is going to be. We look for, this sounds like a heavy term, but we look for buried erosional surfaces. Usually, like, you can spot it as a squiggly line between them. Not always, but you'll get better at spotting these to let us know that that took place. This little diagram, though it looks kind of dated, it's great though. These 4 layers were originally deposited. First was A, then B, then C, then D, right? Then some deformation. What we called up above, we called that folding. Then, at some point, this rock would have had to have been uplifted enough that it was hit by weathering and erosion, and that whole top was stripped right off. And then, at some point after that, probably brought back down below where deposition would take place, and more rock got put on top, giving us that line right there. That's what I mean by this squiggly line. This line right here. That's our buried erosional surface, or our unconformity. All right, that's it. This is the same diagram. 3 rocks, then tilting, then erosion, then subsequent deposition on top, giving us an unconformity right there. Okay. So you could just say, you can really, as far as us just practicing these, you can just say erosion and we'll call it good on that. Now, there are a couple of specific types of those. So don't ignore the text. Check out the difference between, there you go, that table right there wraps them up nice and neat. Okay. Um, the broad categories and conformities, but there's more specific types based on what exactly is above and below the unit. So take a peek at that and we'll be in good shape. So I'll wrap this up, but here's what we'll do. If you want to practice a couple of these and see what kind of questions may show up, I'd say if you can solve all of this, then you're in real good shape. What 3 steps took place to get to this? What 6 steps took place to get to this? What 13 steps took place to get to this? And this one should have the little squiggles. Before I upload yours, I'll excuse me, I'll add those in and make sure that that's up. Okay. Maybe I'll do another quick video just to talk through the answers, but I'd say give it a try, even if it's in your head, to say what must have happened first, second, third, fourth, and so on. All right. Thanks for tuning in. We'll catch you guys soon for the next section.